I wanted to start off my talk with a question, which is what each of these tools have in common. And if you don't recognize the logos, we have Kismet and Snort and Zeek, which was originally Bro, TCP dump, NTOP, Nmap, Wireshark, and Suricata. The obvious thing is that all these tools have to do with network monitoring and analysis and scanning and things like that. But the thing I want to focus on right now is that they're all part of an ecosystem kind of anchored with libpcap. And along with libpcap, if you're running on Windows, originally maybe WinPCAP and nowadays npcap. And being a part of this ecosystem is great for example, when as someone writing a protocol analyzer, using libpcap is great because, as I said, when I'm developing a protocol analyzer, I get to focus on the features that go into a protocol analyzer. I don't have to worry about having to reach down into each individual operating system and deal with their individual ways of capturing packets. I don't have to worry about maybe touching a network driver or network hardware. I can just use the same library, same routines to start captures on each platform. And within WinPCAP and npcap, this does let us run on all available modern platforms. Another cool thing about libpcap is that it has an associated file format, the pcap file format that everybody uses and has been famous for decades now. And I consider that to be a productivity multiplier. If we go back and look at all these different tools and consider what the world would be like if each of these tools use their own incompatible file format, that would not be useful. That would be a hindrance versus a bonus. So, having this common library and these common file formats works really well. A good question to ask, and a question my boss asked, was where we might be able to duplicate this success and duplicate this environment. And one area we can duplicate it is with system calls and logs. And if you have other time series data in an environment you work in, we could pull in that data as well. And to kind of fill you in on why I'm talking about system calls, it would be useful to maybe give a quick history lesson. I originally created this slide just to show you a timeline of things that happened that started out with libpcap and led up to my work, currently analyzing system calls. But as it turns out, this slide also illustrates the fact that when you solve a problem, that's facing you in your area, that you're dealing with day to day, oftentimes when you solve that problem, you end up paving the way for other people to solve problems later on. And I think that's one of the things that I really love about this ecosystem is the fact that we have so many people in so many different areas and fields that have focused on solving problems and let other people solve problems that they later on had many years later. The story starts out with TCP dump and how it came about. I remember years ago, we were fortunate enough to have Van Jacobson give a talk at SharkFest. I mean, this is a long time ago. I looked at the video and I had more hair and it was darker. But he was talking about the time back in the 80s when he was at the Lawrence Berkeley lab and they had a problem. The internet itself was having growing pains, and it was going through something called congestion collapse, where you had a bunch of people on these high-speed LAN links, and I say high-speed LAN, and I'm talking about 10 meg Ethernet, trying to talk on these much slower WAN links, and the TCP algorithms at the time just weren't able to handle that, and so you had this problem with excessive retransmits and all this other stuff that was going on. And in order to kind of get a handle on what was going on, Van Jacobson and his team ended up developing TCP dump and libpcap and VPF and all this other stuff. I don't think that they get enough recognition for the work they did at that time because it had such a huge impact on what we do today. But they did the work and solved their problem, and a little while later, they released what they did as open source. And in I think 1994, libpcap got split out from TCP dump into its own library. That was the first 0.0 to release. But that kicked off another explosion because, they had solved their problem. But like I said, that paved the way for other people to solve their problems. If you look down at the bottom of the slide, you have all those tools that I had in the first slide. And they all kind of started at the same time. Zeek and Ntop and Nmap and Kismet and Snort. And, I started working on Ethereal at about that time in the late 90s. And, the problem that I needed to solve was the fact that I was working at an ISP and I needed an interactive analyzer that ran on Linux and Solaris. And I needed something that if I were to buy a commercial option, I couldn't do that just because we didn't have the budget for it. So I was, decided to, fine, I'll start writing my own analyzer. And that's what I ultimately did. Around the same time, there were a couple of grad students in Italy, Loris De Giovanni and Gianluca Vreni, who were trying to fix a problem on their end. The problem they were trying to solve was the fact that you couldn't really capture packets on Windows, and they ended up developing WinPCAP, which is a libpcap-compatible capture driver for Windows. What ended up happening there was, since WinPCAP became available, it was really easy to take your code that used libpcap and adapt it to run on Windows. And in our case, our user community exploded because there were all these people running on Windows that needed to do protocol analysis, and this let them do that. And and the same thing happened with these other projects. I know Nmap in particular, they have a pretty large Windows user community nowadays, and that's possible because of WinPCAP, and that's why they ultimately developed NPCAP to replace it. So as that Windows community grew, at the same time, 802.11 was getting to be very popular, but it was still kind of new and not very reliable. And so people had a need on Windows to troubleshoot .11. And they weren't able to do that at the time because if you used your built-in NIC and the driver that shipped with your OS and you tried to put that adapter in monitor mode, the driver very helpfully shut everything down. You just didn't see any traffic at all. So I sent Loris an email and said, look, we have a lot of people complaining about this, and they really do need to analyze traffic on Windows and wireless. And so we started exchanging emails, and at that time he had co-founded a company in Davis, California called Case Technologies. And that's when Ethereal became Wireshark, because Loris invited me to come join him at that company, and that's what I did. But I had to leave the trade market behind for Ethereal. And we solved a bunch of problems there. We released AirPCAP, which is a wireless capture driver for Windows. We released a bunch of other products that complemented Wireshark. We hired Janice. I don't see her, but she started SharkFest'. A whole bunch of cool things happened just from solving that initial problem of trying to capture on Windows. And the story continues on. Loris went on to notice that, okay, in the 2010s, cloud computing became very popular, and if you wanted to get a handle on what your cloud machines were doing, that wasn't really possible. You could run TCP dumping into packet capture and run some other local tools, but as convenient as cloud computing is, at least early on, cloud providers didn't really provide you with any insight into what your system was doing at a low level. That's changed over the years, but in order to fix that problem, Loris came out with a command line tool called Cysdig, which works a lot like TCP dump, but it shows you the system calls that are happening on your system. And by fixing that problem, he actually started a company called Cysdig as well, but by fixing that problem, people noticed that, okay, I have other needs as far as capturing system calls. It would be really handy if we were able to look at those system calls and look for anomalous activity and maybe trigger rules and alerts on that. And that's what ended up being addressed with a tool called Falco. Right now you can run Falco on your systems, and it works a lot like an IDS and will alert you to suspicious activity. Let's see. But like I said, that initial work that Van Jacobson and his team did not only ended up with this course of events, but if you look down below, it also we could also draw timelines from any of these other tools and see how they developed over time just because of this initial work. If you look at the Linux kernel right now has ePBF built in, and that's because of the initial BPF work that team did on TCP dump. So, like I said, I don't think they get as much recognition as they should for how much they've impacted our industry. So when I talk about system calls, if you aren't familiar with what they do or what they are, one way of looking at them is kind of this boundary layer between the operating system on your machine and the processes, the applications, and the programs that run on top of that operating system. Anytime a process on your system wants to do anything useful, interesting, typically it goes through the system call interface. For instance, if you want to open a network connection or read or write a file or play a video or play audio or whatever, you're going to go through the syscall interface on that system. And on Linux and Mac OS, the system calls have the same name and they operate the same because they adhere to a standard called POSIX. On Windows, the names are a little bit different, and it works differently enough that it's kind of annoying sometimes, but the overall concept is the same. You have this layer of system calls between your apps and your operating system that allow your system to do work. And from an application perspective, this is very convenient because if I want to read a file, I just end up calling the open system call and followed by reading the read system call several times until I have that file read, followed by close. And when I call those system calls, I don't really have to care if that file is on an SSD or on a spinning Rust hard drive or on a USB stick or on a file share. It works the same. And on the operating system side, I get to do things like enforce security boundaries. If that application is not allowed to read that file, I can say, no, sorry, you can't do that. You don't have permissions. And so, we have a situation where we have all this interesting activity happening on the system call interface at that layer on the system. And if we look at a modern Linux system where we have a bunch of containers typically running a whole bunch of processes and a whole bunch of activity, like, for instance, if this was a host in a Kubernetes cluster, the situation is such that we can get a lot more use out, we can get a lot better handle on what's happening on the system if we are able to tap into that system call layer. So if we had a tap there, we can really see what's going on in the system. And that's what the tools that Cysdig makes do. Cysdig and Falco are based, or they sit on a couple of libraries. One is called libscap, which stands for Library for System Capture, and it can tap into the syscall level on a Linux kernel a couple of ways. You can use a kernel module or an ePBF probe. It also has a plugin interface, so you can pull in CloudTrail logs and Kubernetes logs and any sort of time series data that you want to provide. That's what I was referring to in one of the earlier slides. Where if you have just this unique time series data in your particular environment, you could write a plugin and pull that in. On top of libscap, we have libsimps, that stands for Library for System Inspection, and it enriches the data that comes out of libscap. It does things like correlate usernames with the user IDs and file names with file descriptors and things like that. So the tools that Cysdig makes sit on top of that, and that's how they get their system call data. The thing is, we have this kind of thing that works like TCP dump and this thing that works a little bit like an IDS. The question then becomes, what if we add another tool, one that let you do interactive analysis? What if we took Wireshark's user interface and Wireshark's dissection engine and plugged it into these libraries? What would that look like? And that's what we have today. This is what I've been working on at Cysdig. We have a tool which we are calling Stratoshark, and it's a sibling application to Wireshark, and that's what hopefully I can show off if my computer will let me display it. But I'd like to do a quick demo. As the disclaimer says at the bottom, this may contain traces of danger and stupidity. because whenever I give a demo, it's usually for something that I'm currently working on, which means that I'm working off the very latest bleeding edge code in Wireshark's source code repository. So I might erase everybody's computer here. I don't know. We'll see. So this is Stratoshark. It should look familiar. At the top, we have a list of files that I have captured previously. At the bottom, there's this thing that looks like an interface, but it's not quite an interface. It's actually a capture source for CloudTrail logs. If I open up a capture file, again, this should look familiar. We have a list of things at the top, which, well, wait a minute, they're not packets. They're actually system calls. If you look at the different columns, we have a process name, we have a system call name, we have a username. Sorry, this is kind of a boring capture because all I did was capture a curl process downloading something off the Wireshark website, because I'm not clever that way. But if we go through and look at this, we have coloring rules applied to the system calls. This, like I said, should look very familiar if you're a Wireshark user. Down below in the detail area, I can look at information on this particular process, and there's a lot of information that's there, and that's because libscap gives you that and libsimps give you that information. I can go and look at the process ancestors, and again, this is part of the enriched data that libsimps provides. Since we're using the same UI code and the same dissection engine, I can apply a display filter. For example, if I want to see all the activity in the etc directory on my system that this process did, I can do that. And if I scroll down and look, I see that since I ran curl, and it connected over SSL, it needed to read the CA-cert file on the system. And if I right-click, I can follow. In this case, it's not a TCP stream, it's a file descriptor stream, but I can see the contents of the file that it read. If we go back and look for activity in the lib directory, scroll back to the top, I click down here. If we look down at the detail view again, we see all the process information, but at the very bottom, it says executable in linkable format. Does anybody know what that is? ELF? Tell us, Peter.
It's binary format on Linux.
Yep, it's the executable format that Linux uses for binary executables. And in this case, we're combining the power of libsimps and Wireshark, because libsimps doesn't know about ELF, but Wireshark has an ELF dissector. How many people here knew that if you're on Linux, Wireshark can open Wireshark? Well, the core developers did, but yeah, if you're on a Linux box, try that. But we can go down here and see that we opened an executable file, and I can go look in that ELF header and examine that. We're kind of limited on time, so I think that's probably all the time we have for demo. But where's my web browser? Okay. To answer a couple of questions about Stratoshark, you might want to know if you can download this and try it out. The official answer is we're going to have it at launch next year, probably around early February. The unofficial answer is right now you can go download automated builds from our automated build directory for macOS and for Windows. So if you want to try it out, go ahead. If you want to do any sort of capture, you can do it locally on Linux, but you'll have to, if you want to get a system call capture, you'll have to run Cysdig on a Linux box somewhere and capture that data somehow. Let's see, to cover a couple of other issues, please be aware that this is in addition to and not instead of Wireshark. This is a brand new sibling application that's part of this ecosystem that we have. There are still a lot of rough edges. I mean, we're basically taking this thing that was really focused on packets and trying to expand that out and include system calls and log messages and things like that. Finally, if you look at Stratoshark right now, it's the menu items are kind of sparse, and that's on purpose. I wanted to have this blank slate. When I split off the UI code into a new application, I intentionally ripped out all the wireless and telephony and a bunch of the analysis menu items because those are all focused on specific protocols, and I wanted to have this sort of greenfield, this empty blank space that we could use to fill in features that covered system call analysis and log analysis. And those features are going to probably take years and maybe decades to fill in completely, but I'm really excited about that work that lies ahead. If you were at SharkFest US, you might have remembered that I showed this off, but it was under the name LogRay. And this has actually we're on the fourth name now. It started out as LogShark, and then LogWolf, and then LogRay, and now Stratoshark. That's just part of the process of developing a product. We ultimately decided on this name because when you think, I think Stratoshark makes a lot more sense, and I like the name because when you think about it, Wireshark lives in your network and Stratoshark lives in your cloud. That's a really, I think, good and concise way to put it. And also, much as I like the name LogRay, it's a great name, but that word log is in there, and it doesn't really. It's kind of misleading because this application does cover system calls and does have quite a big, strong focus on that. Oops, there we go. And as our marketing team at work pointed out, we would be really, really stupid to not use Shark in the name just because it's such a strong brand. And so, now we have Stratoshark. And I've actually, as time goes on, I'm more and more excited about that. This is the time in the keynote when we invite the core developers to come up.
Hi, I'm Graham Blois, been involved in Wireshark since the last century. And it's just great to see so many people, along with the core developers, still enjoying working with Wireshark, still developing Wireshark, and still responding to everybody's needs around that area of network capture. And as we've seen there, Stratoshark will start moving that on into other areas.
Yeah. Now, weren't you one of the people who did the initial Windows port?
Well, Windows was there, but you couldn't do live capture, which was very frustrating. So I did the first attempt at allowing live capture on Windows. That's now been superseded with a much better implementation. That's my small claim to fame. And also on the help dialogue about Wireshark, the copy to clipboard button, which was essential so that we get the information about what you're actually complaining about.
Hi all, my name is Pascal from France. Thanks for joining us in this great place and sharing a bit of your time with us. I've been in the wireless telecom industry since the last 25 years, using Wireshark every now and then, and just played a bit with it and started contributing. And it's quite easy to do so do not get feared or whatever. Come and see us in the developer den if you have any question.
Yes, hello, my name is Stig, I'm from Norway. At the time, 20 years ago, I was working in military industry with military protocols, so we needed Wireshark for this. And we also had a project, a bit like Gerald Stratoshark, we did internal messaging system tracing. So it was completely different, but it was the same. So we just exported things to PCAP, had it displayed in Wireshark, and this is the point where I made the profile support, because I wanted to have different columns, different behavior, different everything, which still was the same. And nowadays I think everyone is using the profile because they have different behavior in their systems. So contributing to Wireshark is a nice thing, and it benefits many people.
Good morning, my name is Jaap, I'm from the Netherlands. I came into contact with Ethereal and Gerald when the voice over IP thing was starting to happen, and I was looking for tools to be able to develop that and support us in that. There weren't many. This was close, but not close enough. So I started to do some changes, some additions, and Gerald eventually had enough of handling my patches. So he said, "Do it yourself," and that's sort of what I've been doing ever since. Try to help out with bugs and issues which have been raised, requests that have been made on improvements, and most importantly, watching you guys working with Wireshark and see what you do, what issues you come into contact with, what you see happening, what could be made more easily accessible, all that stuff. For this, we need input from you guys. So even if it works or doesn't work like you wanted it to work, please come see us in the developer den and talk to us about what you're doing and what you're facing in your day-to-day activities, so that we can see if and how we can improve that experience. For us, that's vital input to make this an even better product for you guys.
And for me.
And for you.
Hi, I'm Sake, also from the Netherlands. My journey with Ethereal started like in 1999, so the last millennium even. I was working at the time. I was working at a bank, and then I moved over to a reseller, and I used Wireshark to troubleshoot a lot of issues and bugs in mainly load balancers. And I was missing features, and then you can ask for it, or you can just download the source code and see if you can fix it yourself, which I did. And I'm a very intelligent copy and paster, so I look at the Wireshark. Where's a feature that looks like my feature? Okay, take the code, adjust it to my needs, and so I submitted quite a few things, and then I was also given write access to the repository. That means you become a core developer. That was a long time ago. My development days are kind of over. My main focus at the moment is doing training, presenting here, all kinds of answering questions on Ask, bugging the core developers with things that I, in my daily work, encounter that are not working right. So my role in the team has changed a bit, but it's a great family to be part of. So yeah.
Hello, my name is Eugène from France. I joined the team recently, and I like to solve bugs and to work on features. So I'm happy to be here today.
Welcome.
Thank you.
Hello, my name is Joachim from Sweden. Same, I joined quite recently as a core developer, but I've been using Wireshark for over 10 years, where I joined a very big Swedish telecom company, where first day I just used Wireshark and had problems from the first day. Yes, so, but internally I found Anders here, works in the same company, so I bugged him a lot in the beginning. But as the classic way goes, that you have a problem, solve it yourself. Yeah. So Anders encouraged me to actually solve all the problems, which made me do a lot of commits. And then I'm here today as a core developer. So thank you, Anders.
So my name is Anders Broman. I started with Ethereal Wireshark back in 2003. Similar as JAP, actually. It was voice over IP and ASN1-based protocols, which wasn't very well supported in Wireshark at the time. But there was a guy working on that and solved the problems, and I chimed in and fixed some things there as well. And after that, I was actually maintaining Ericsson's internal version of Wireshark for 10 years or so, or more. I'm now retired, but I'm still working on Wireshark as a hobby and do a lot of code reviews and things.
Hello, my name is Uli from Germany. My e-serial journey started also as working as a network engineer and missing features, or the dissector didn't dissect what I need to do to debug things, and that was the first commit. And as all the others already said, it's easy to contribute and just do it. You don't need to be a programmer.
Hi, I'm Peter from the Netherlands.
story might probably also seem familiar. About over 10 years ago, I was very involved in open source development. I tried to use Wireshark to do some TLS decryption. It did not work as I expected, so I started getting the source code, fix it up, address a couple of needs, add the awesome tree, and so on, so on. Whenever I have a problem that Wireshark can help me with, I try to fix it and hopefully help all of you also understand what's going on better. And nowadays I work at Cloudflare, where we also develop all kinds of new low-level protocols. So Wireshark is also very useful there, and being able to add new features to Wireshark is also very helpful there.
So I'm not boring with the same story. Yes, I had a problem. Yes, I fixed it. In my case, industrial automation. But it's pretty much the thing. You can contribute to Wireshark in any ways you want. One of the more beneficial ones when you're not into coding, for instance, would be Discord. By the way, my name is Roland. I'm the residual Austrian on the team. And Discord is a great tool for us to, get people together, talk about issues. We have a somewhat active community, I have to say. I think we're now about 6,000 people registered on that platform, which is quite nice. And yeah, that's our preferred way. And just to give you an example of what can actually happen if Wireshark comes into play, some of you might heard there's a new protocol out there called Matter, which is the new smart home protocol for the future. The Wireshark dissector was fully functional before the first implementation of the protocol was written. And it hasn't been changed due to changes to the protocol at all until the first version was released. So that's kind of a thing what Wireshark can do. It's a developer tool, but it's also a user tool. It's a investigation tool, forensic tool. Just a really cool tool that can do a lot of things that you might not heard of or might not use. So yeah, get involved. We welcome you with open arms and a long bug list. On GitLab, yes.
Yeah. Did anybody have any questions for the development team? We can probably do one or two. Well, great, everybody's filled in.
Perfect.
Yeah.
Cease work now.
Yeah, we're done. No, if you have any questions or if you want to talk to any of us, just stop by the developer den. We're happy to talk to you. Okay.
Yeah, just because you noticed it yesterday, we may look very intense working when you walk into the room. Don't bother. Just, ask loudly, and about 6 people will answer happily. If you have a laptop problem, this guy will help you. No, it's just a fun story on how we think, because in San Diego, somebody had a problem with their laptops, and Peter, being not able to help himself, started to do hardware debugging because, of course, that's what we do. No, we really, really want to hear from you, hear your stories, hear your needs, hear your problems, and, just be interactive.
All right. Actually, if you want to stay up on the stage, actually, I'm going to go ahead and skip over the slide because we're short on time, and this is all. I'm assuming you're running 4.4, and you of course have read the release notes because everybody does. So I don't need to do this slide.
Wait. Could you one back?
Yeah.
Please, everybody, try to figure out what this one is. It will change your investigation life. Automatic profile switching. This will really change your investigation life.
No, I can give it a clue. Sorry. At first I thought this is a useless feature, for me at least. There's probably people that really need it. Then I thought, maybe I can use it too. So yesterday I tried it out. I put a comment in the first packet saying profile, colon, and then the profile name I want to use for it. And I created a filter to say, if the frame comment is this profile, use this profile. So now you can easily just tell in your capture file which profile to use.
Well, aren't you clever?
You have to bend the rules a little bit, right? So that's the way to.
Yeah. Anything else, Roland, on that? Okay. Since we've done a major release, of course, the next question is, when's the next version of Wireshark coming out? The answer is, none of us know. The considerations that go into coming out with a major release are, kind of how much time has elapsed since the last release, how many features we've accumulated and whether or not they're significant, what our library dependencies are doing. For instance, Qt, our user interface library, just came out with the current long-term support version of that library, which is 6.8. We need to wait for that to kind of settle down. Another consideration is the operating systems that we support. For instance, various Linux distributions have long-term support life cycles, and if we can kind of do a release after a particular LTS Linux version reaches into life, that means that we can maybe stop supporting some really old libraries that cause us some pain. So there are all sorts of considerations. My best guess is that we'll probably have another release in the summer, probably after SharkFest US. We'll see what happens. Right.
If there is something that you need to be still supported at that time, what we do, we have not one release version, we actually have 3 consecutive releases. So we do still support for a certain amount of time the older versions as well. For instance, if you only can run Qt 5, then you're somewhat stuck with an older version of Wireshark, but at the same time you get a version that works on your PC, you get pre-built binaries. The reason for that is you have to imagine none of us, except Gerald maybe, is paid for working on that project. It's a hobby for all of us. So if you get frustrated because, I don't know, it's not your supported platform or it's not particularly useful anymore on your platform, that's one of the reasons why we need a guy who has the same need to at least try to make it work there as well. So bear with us. We try to support as many stuff, most stuff that we can. And Ericsson got you covered for really old Red Hat releases. So if you have a corporate Linux system, that will help.
And there's always the development release. It's most of the time fully functional and safe to use. So if you're looking for the newest, brightest protocol dissectors or new features, by all means, take one of the nightly builds.
And then also we have the automated build, which is really, really new. And yesterday I showed some issues to Stick and to John, like, okay, I'm having problems with this, and they're fixed already. So it's not a guarantee that if you walk into the developer then that it's fixed during SharkFest, but the chances are really high because everybody's together here talking about it. So, yeah, no pressure.
But that's one of the things I love about the project, and it's something we've been able to do for a very long time, since we have this automated build system. It's, sometimes when somebody reports a bug, if it's easy to fix, you can go, okay, it's fixed, and here you go, here's a release that you can download in about an hour or so when everything gets, finishes running and packaging up. And we can turn around those fixes very quickly for people, and that's very, very useful. I have 3 more slides. If we can, I know we're kind of going over time, but I'll try to power through them. Just some vital stats on the project. Wireshark right now is somewhere between 3.5 and 6.5 million lines of code, and that ambiguity comes from whether or not you count code that's automatically generated. If the automatically generated code is about half of our code base right now, which is actually really, really good. I mean, it makes for, I think, better quality code, or at least more manageable. We get about 1.5 million downloads a month on the servers that we manage, but I don't know, for instance, how many users we have on the Linux side and how many downloads a month we have there, because they just pull Wireshark through their packaging systems, which I have no visibility into. But on the servers we manage, most of our downloads are for Windows. A pretty good portion are for Mac OS, which kind of matches the general population. Roland, you said we had a lot more than 4,100 Discord users? Okay. Well, shame on me for not updating that. We're up to 3,000 protocols supported in Wireshark, along with 250,000 display filter fields, which really does, speak to the power of all those dissectors and being able to filter on all those different fields. We're up to about 2,300 authors, 2 yearly conferences, and the next slides are about the one foundation we have. We do have this nonprofit now behind Wireshark that we started up last year. Up until that point, Wireshark had been sponsored by whoever I worked for at the time, which was great and convenient, but at the same time, there was kind of a single point of failure for funding there. And since starting up the foundation last year, we have a lot more. We don't have that single point of failure. The project, I think, is in much better shape, but at the same time, we have to find sources of funding for the foundation. Fortunately, we have sponsors like NDACE and Veeam and NPCAP, who are project members and sponsors, but we do need to raise money for the foundation. Janice mentioned that last night, and she mentioned the raffle that we're having for people donating $20. But this is the point in the talk where I beg for money, basically. But if you want to help the project and the foundation, we would be very appreciative, and it goes to support things like SharkFest and support the development work that we do, and pay for our staff and things like that. And if you want to donate individually, that's fine. It would be even better if you could somehow get a recurring donation set up, because that helps us plan on our budget. But the really cool thing you could do would be to get your employer to donate, because your employer has a lot more money than you do, first off. And if your employer gets a benefit from Wireshark, I think there's a very good argument to be made there to donate to the foundation, because you have this useful protocol analyzer that if they can kind of donate money, that would make us a lot more healthy and improve our chances for the future.
So just to say thank you to everybody who has donated.
Yeah.
You can still donate at any time, but it's good for us to see in the project that people are willing to support the foundation, and we thank you all very much for that.
One of the things that we've run into, since we started having our own nonprofit, is the fact that when we do put on conferences, the hotel wants to be paid like months in advance. I think the hotel, if they could be paid a year in advance, they'd do it. They would insist on that. But so we have to pay all this money up front, but at the same time, the attendees don't, they get to pay for the conference much later on, and so we have this gap that we need to fill in, and that's just one of the challenges that we have with the funding. So I'll stop talking about that. Finally, I wanted to wrap up by saying thank you. I make a point to say this every time, but Wireshark is a great and wonderful thing, not because of me, it's because of you all, because of the development team and the educators that teach you how to use Wireshark, and the people that come to conferences like this, and everybody else that's involved with this community. It's a wonderful community, and I cannot thank you all enough for all that you contribute. So, thank you.